Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on demonstrating Azure Cognitive Search in conjunction with the Azure OpenAI service. This will be a hands-on guide with code examples to help you understand how to combine these powerful services to build intelligent search experiences. Tutorial: Building a semantic search application with Azure Cognitive Search and Azure OpenAI service. Goal *. We'll build a simple search application that allows users to ask questions about a set of documents, example product descriptions, company policies, research papers. The application will leverage the Azure OpenAI service to generate embeddings, vector representations, of both the documents and the user's query. It will then use Azure Cognitive Search to perform a similarity search based on these embeddings, retrieving the most relevant documents. Finally, the results can be presented to the user. Prerequisites *. 1. Azure subscription *. You'll need an active Azure subscription. If you don't have one, you can create a free account. 2. Azure Cognitive Search Service *. Create an Azure Cognitive Search service in the Azure portal. Note the service name, resource group, and key. A basic tier will work for this demo. 3. Azure OpenAI Service *. You'll need access to the Azure OpenAI service. Request access if you don't have it. Create an Azure OpenAI resource in the Azure portal, and make sure the region you choose has the models you want to use available. Note the service name, resource group, endpoint, and key. 4. Python environment *. Set up a Python environment with the necessary libraries. I recommend using a virtual environment. 5. Editor * VS Code, Jupyter Notebook, or your preferred IDE. Step 1. Install required Python libraries. Open your terminal / command prompt and run the following command to install the required libraries. * Azure Search Documents, for interacting with the Azure Cognitive Search service. * Azure Core Azure Client Library. * openai, for interacting with the Azure OpenAI service. * tick token, for token counting in OpenAI prompts. * Python.env, for managing your secrets. Step 2. Set up environment variables. Create a .env file in your project directory and add the following environment variables. Replace the placeholder values with your actual service information. Important *. Never commit your .env file to a public repository. Step 3. Load environment variables. Create a Python file, example app.py, and add the following code to load the environment variables. Step 4. Create the Azure Cognitive Search Index. We need to define the schema for our search index. This schema defines the fields that will be stored and searched. Explanation *. We import the necessary classes from Azure Search Documents. Create _search _index, this function encapsulates the index creation logic. Search Client, creates a client to interact with the Azure Cognitive Search service. It takes your service endpoint and API key as arguments. Fields, defines the schema for the index. ID, a unique identifier for each document, string, key. Title, the title of the document, string, searchable. Content, the main content of the document, string, searchable. Content _vector, this field stores the embeddings, vectors, generated by the Azure OpenAI service, collection of single/float, vector search dimensions needs to be set to the proper dimension. HNSW algorithm configuration, this is the configuration that creates the actual algorithm configuration for vector search. Vector search profile, This is the vector search profile to be associated to the content_vector search field. Vector search. Vector search contains all configurations for vectorization. We use a try except block to handle potential errors during index creation, example if the index already exists, or if there are permissions issues. Important considerations for the schema vector search dimensions. Set this to the correct dimension size of the embeddings generated by your chosen Azure OpenAI embedding model. Text embedding ADA002 uses 1536 dimensions. Vector search profile, the vector search profile to use with this field. If you have additional metadata you want to store and search on, example author, publication date, add corresponding searchable field or simple field definitions to the fields list. Step 5. Prepare your data and generate embeddings. Now, let's prepare some sample data and generate embeddings using the Azure OpenAI service. Explanation generate _embeddings, text, initializes the OpenAI client with your Azure OpenAI endpoint and API key. Calls the openai.embedding.create method to generate embeddings for the given text using your chosen embedding model. Handles potential exceptions during embedding generation. Load _documents, file _path, loads documents from a JSON file. The JSON file should contain a list of dictionaries, where each dictionary represents a document. The dictionary should have fields ID, title, and content, or you can adapt the code to your specific data structure. We iterate through the documents, generate embeddings for the content field, and create a new list indexed _documents that is ready to be uploaded to Azure Cognitive Search. Step 6. Upload documents to Azure Cognitive Search. Now, we'll use the Azure Search Documents library to upload the prepared documents, with embeddings, to your Azure Cognitive Search index. Explanation we create a search client to interact with your Azure Cognitive Search service. Upload documents. Calls the search client.upload documents method to upload the list of documents. Handles potential errors during the upload process. Step 7. Perform a vector search. Now, let's implement the core functionality, performing a vector search using the user's query. Explanation search documents, query. Generates embeddings for the user's query using generate embeddings. Creates a vectorized query object. Vector, the embeddings of the query. K nearest neighbors, the number of nearest neighbors, documents, to retrieve. Adjust this value based on your needs. Fields, the vector field to search on, example content _vector. Calls the search client.search method to perform the vector search. Search text equals none makes the search a pure vector search. Select specifies the fields to retrieve from the search results. This is important for performance, as it avoids retrieving unnecessary data. The results are an iterator, so we convert to a list before returning. We then iterate through the search results and print the ID, title, and content of each retrieved document. Step 8, optional, improve results with semantic ranker. Azure Cognitive Search also offers a semantic ranker, which can re-rank the results based on semantic relevance. You can incorporate this to potentially improve the quality of your search results, but note that it incurs additional cost. To use semantic ranker, you need to create a semantic configuration for your index. This is done in the Azure portal. Go to your cognitive search service, then indexes, select your index, and then semantic configurations. Create a new configuration with appropriate field mappings. Then, modify the search_documents function. Changes *** semantic _configuration_name, pass the name of your semantic configuration. * query _type equals semantic, enables semantic search. * you also need to provide the query to search_text. Semantic ranker uses the query text to understand the intent and re-rank the results. * other arguments related to the quality of the response. Step 9, optional, incorporate large language model, LLM, for question answering. Instead of just showing the search results, you can use an LLM, like GPT 3.5 Turbo or GPT-4, to generate a more concise and informative answer based on the retrieved documents. Explanation **** generate _answer, query, context. * constructs a prompt that includes the user's query and the relevant context, the content of the search results. * calls the openai.completion.create method to generate an answer based on the prompt. * adjusts the max_tokens parameter to control the length of the generated answer. The temperature parameter controls the randomness of the generation, lower values result in more predictable responses. We concatenate the content of the top search results to create a context for the LLM. The generated answer is then printed to the console. Important considerations prompt engineering the quality of the generated answer heavily depends on the prompt you construct. Experiment with different prompt formats to optimize the results. Context length LLMs have a limited context length, the maximum number of tokens that can be included in the prompt. Make sure the combined length of the query and the context doesn't exceed the limit of your chosen model. Cost using an LLM for question answering incurs additional cost, as you're paying for token usage with the Azure OpenAI service. Complete AppPy example To run the code *. 1. Save the code as AppPy. 2. Create a data.json file with your sample data. 3. Make sure your .env file is properly configured. 4. Run the script from your terminal, Python AppPy. Next steps and further exploration User interface build a web interface, using Flask, Django, Streamlit, etc., to allow users to enter their queries and view the results in a user-friendly way. Data pre-processing implement more robust data pre-processing techniques, example cleaning, stemming, lemmatization, to improve the quality of the embeddings and search results. Chunking if your documents are very large, consider breaking them into smaller chunks and generating embeddings for each chunk. This can improve the granularity of the search. Hybrid search combine vector search with keyword-based search, using the search_text parameter in the search_client.search method, to leverage the strengths of both approaches. Fine-tuning fine-tune your Azure OpenAI model on your specific data to improve its performance on your task. Monitoring and logging implement monitoring and logging to track the performance of your application and identify potential issues. Error handling add more comprehensive error handling to make your application more robust. Authentication and authorization secure your application with proper authentication and authorization mechanisms. Multi-tenancy if you need to support multiple users or organizations, implement multi-tenancy to isolate their data and resources. Scalability. Design your application to scale horizontally to handle increasing traffic and data volumes. This tutorial provides a solid foundation for building semantic search applications with Azure Cognitive Search and the Azure OpenAI service. Remember to adapt the code and configurations to your specific needs and explore the advanced features of these services to create powerful and intelligent search experiences. Good luck.